Dear student, first lesson, measurement. First of all, we have to know physics before learning measurement. Okay. Physics is a study of nature and natural phenomena. Natural phenomenon means what? Lightning, thundering, evaporation, vaporization, rotation of earth, revolution of earth. Okay. So study about this natural phenomenon, that study branch of science, that is called physics. Okay. Physics is considered as the base of all science subjects. Physics is based on experimental observations. What's the use of measurement? Theories in physics use many physical quantities that have to be measured. Measurement is the base of all scientific studies and experimentations. Okay, with the use of measurement, then only we can calculate many observations, many things. Okay. Then measurement. What is measurement? Measurement is the process of finding an unknown quantity, unknown physical quantity by using a standard quantity. Okay. For example, if on physical quantity, length, unit of length is meter. We know meter or centimeter or kilometer. But we don't know the value, unknown. That is number. So the unknown means what? It's number. We don't know the particular number. Okay, so that's unknown quantity by using standard quantity, that is unit. So that this comparison, that is called measurement. For example, unit of science textbook 35 centimeter. So here we don't know this number 35. Okay, but we know centimeter. Unit of length is in centimeter. So this comparison unknown with known. This is called what? Measurement. Clear? Then next one, what are the three things for a perfect measurement? They are first one, an instrument, second one, a standard quantity, then next one, acceptable unit. And first one, instrument. The length, the instrument means what? Ruler is instrument used for measuring length. Okay. Then the length is the physical quantity, and 15 centimeter, that is what? 15, that is magnitude, and centimeter is the acceptable unit. Clear? So that process is called measurement. Clear? The next one, what are the systems of units? FVS, CGS and MGS. FVS, capital F, that means what? Foot for length, pound for mass, and second for time. CGS system, C, centimeter for length, gram for mass, and second for time. MKS, meter for length, kilogram for mass, and second for time. MKS, first letter M, K and S. CGS, C, G and S. Oh, clear? So these are the three systems of units. Next one, international system of units. International system of unit and is popularly known as SI system, abbreviated from the French name System International. All over the world, international level accept this unit. Okay. Next one, the scientists choose 7 physical quantities as base quantity. That is a physical, that is the fundamental quantities. It is defined as a standard unit to measure each one. Okay. For example, unit of length is meter. Okay. These are 7 fundamental quantities: length, mass, time, temperature, electric current, amount of substance, and luminous intensity. Okay, once again, length, mass, time, temperature, electric current, amount of substance, and luminous intensity. These are all 7 fundamental or base quantities. Then unit of length is meter, unit of mass, kilogram, unit of time, second, small s, okay, small k, small m. Unit of temperature, small Kelvin. Unit of electric current, small a ampere. Unit of amount of substance, MOL is small m. Unit of luminous intensity is candela, small c. But its symbol. Unit of length, meter, is symbol small m. Kilogram, small kg. Second, small s. Kelvin, capital K. Ampere, capital A. Mole, MOL. Candela, series, small. Okay, but here we use capital K and capital A because this Kelvin and ampere are units named after scientists. Clear? The next one, what is temperature? Temperature is a physical quantity that expresses the degree of hotness or coldness of a substance. Okay. Hotness or coldness of substance. That's two are called what? Temperature. If it is cold or hot, but this is called what? This physical quantity is temperature. Clear? Then temperature is defined as the measure of average kinetic energy of the particle in a system. Okay, so this particle move, so it get kinetic energy. So this average kinetic energy is called temperature. SI unit of temperature is Kelvin. Then the instrument used to measure temperature are called that instrument what? Thermometer. So thermometer is an instrument used for measuring temperature. Okay, thermometer used for this. Next one, lower fixed point and upper fixed point. So these are three scales of temperature. It is first one Fahrenheit scale, next one Celsius, next one Kelvin scale. Here this water boils at this 212 degree Fahrenheit or 100 degrees Celsius or 373 Kelvin. So this is called upper fixed point. Then water freezes at 30 degree Fahrenheit or 0 degree Celsius and 273 Kelvin. This is called lower fixed point. So the difference between 212 and 32, that is 180. 100 minus 0, that is 100. Difference between this is 100. 373 minus 270, difference between this is 100. Okay. The next one, conversion of scales of temperature. Converted Celsius to Fahrenheit or Fahrenheit to Kelvin or Kelvin to Celsius. Use this formula. C by 100. C minus, this is the lower fixed point 0 degree, divided by difference between them is 100. Upper and lower fixed point is difference is 100. That is equal to Fahrenheit F minus 32. This is the lower fixed point. Then the difference between lower and upper is 180. So F minus 32 by 180. That is equal to K minus, this is lower fixed point 273. Difference between upper and lower is 100. Okay. So study this formula. You can convert Celsius to Fahrenheit or Fahrenheit to Celsius or Fahrenheit to Kelvin or Kelvin to Fahrenheit or Celsius. Okay. Then the application of various thermometric scales. Physicians use clinical thermometers. It is graduated in Fahrenheit scale. Okay. The scientists used to are Kelvin scale. Then common temperature measurement are made in Celsius scale. So these are three scales of temperature. Fahrenheit scale, next one Kelvin scale, another one is Celsius scale. Celsius scales used via weather reporters. Okay, weather reporters used to, reports are given in Celsius scale. Clear? Then next one, normal temperature of our human body is between 98 degree Fahrenheit and 98.66 degree Fahrenheit. Infrared thermometer, this is infrared thermometer. This is used to measure the temperature of an object without any physical contact. Temperature of our body without any physical contact. Okay. Next one, electric current. This is another one, physical fundamental quantity. Flow of electric charge in a particular direction is known as electric current. So this flow of charges in a particular direction, this is called what? Electric current. The magnitude of electric current is amount of electric charges flowing through a conductor in 1 second. Magnitude is I is equal to Q by T. Q means charge divided by T, 1 second. So the amount of charge flowing in 1 second, that is called the magnitude of electric current. Okay. The SI unit of electric current is ampere and it is denoted by capital A. Unit of charge is what? Coulomb. Clear? Next, this instrument, ammeter, is a device used to measure electric current. The definition of ampere. 1 ampere is defined as 1 coulomb of charge moving in a conductor 1 second. Q charge, T time T, 1 second. So charge moving in 1 second, that is called what? 1 ampere current. I is equal, unit of current is I, 1 ampere. Clear? So 1 ampere defined as 1 coulomb of charge moving in a conductor in 1 second. That is called what? 1 ampere. Clear? Next physical quantity, the base quantity, amount of substance. Amount of substance is a measure of the number of entities or particles present in a substance. Generally, the amount of substance is directly proportional to the number of atoms or molecules. The SI unit of amount of substance is mole and is denoted by MOL. So what is mole? Mole is defined as the amount of substance which is contained 6.023 to the power 23 entities, 23 particles. Okay. So 1 mole, it means what? 6.023 into the power 23 entities. Okay. The number of 6.023 into the power 23 is known as Avogadro number. So Avogadro number means what? 6.023 into the power 23 particles. Clear? Next one, luminous intensity. The measure of the power of emitted light by a light source in a particular direction per unit solid angle is called luminous intensity. The SI unit luminous intensity is candela and is denoted by CD. Okay, so the power of light emitted by a light, this is light source in a particular direction. Okay, so this is called solid angle. So per unit solid angle, so this is power of light emitted. So this is called what? This is called luminous intensity. Clear? Its unit is what? Unit of luminous intensity is candela denoted by CD. Luminous intensity is measured by a photometer. This is called photometer. Okay. Luminous intensity meter, otherwise called, which gives the luminous intensity in terms of candela directly. Luminous intensity or luminous power is the measure of the perceived power of light. That's its unit is lumen. Okay. Perceived power of light. This is called luminous flux or luminous power. Okay. Next one, plane angle. It is the angle between two intersection of two straight line. Okay, this between these two, this angle is called this one plane, another one plane. So angle between these two plane are intersection of two planes, are two straight lines. Here listen, this is one plane, another one plane. So the angle between these two plane, this is called what? This is called plane angle. The SI unit plane angle is radian and is denoted as rad. Okay. Okay, this angle between these two planes, this is called what? Theta, this is plane angle. Okay, 1 radian is equal to 180 by pi. Next one, solid angle. It is the angle formed by 3 or more planes intersecting at a common point. Oh, okay. Intersecting at a particular point. So the angle formed between, not two, between two or more planes. It can also, that means cone shape, okay. It can also be defined as the angle formed at the vertex of the cone. This is called what? Vertex of the cone. Clear? So the SI unit of angle is, this is vertex. Okay. O is the vertex. So SI unit of solid angle is steradian and is denoted by SR. Okay. Next one, definition. Steradian is the solid angle at the center of a sphere. Okay, this is a sphere. This is center. Okay. So this is solid angle at the center of the sphere subtended by a portion whose surface area is equal to the square of its radius of the sphere. This is radius. So the surface area is square of its radius of the sphere. So this is called steradian. This angle is called steradian. Clear? Next, what is the difference between a plane angle and a solid angle? Plane angle is two-dimensional. That means between two straight line. Okay, between two plane or two straight line. So this is two-dimensional. But here solid angle is a cone shape. So it is a three-dimensional one. The next one, analogical to a triangle, square or circle. Here analogical to a cone or cube or as resemblance, okay, or sphere. Clear? Next one, its unit is same. Both are same. Its unit is radian. Here solid angle, unit of solid angle is steradian. So these are the differences between plane angle and solid angle. Next, clocks. Clocks are used to measure what? Time intervals. Okay, these are clocks are used for measuring time. Types of clocks based on display. This one is called, this is analog clocks. Okay, analog clocks. This is digital clock. Okay, so we can see the time in a digital manner. This is electronic clock, otherwise called what? Electronic clock. This is analog one. This is digital one. Okay. The next one, types of clock based on working mechanism. Quartz clock, first one, and that is its accuracy of 1 second in every 10 to the power 9 seconds. Its accuracy. Atomic clock, accuracy of 1 second is in every 10 to the power 13 seconds. So more accuracy what? This is atomic clock. Accuracy of 1 second in every 10 to the power 13 seconds. Here 10 to the power 9 seconds. So this is more accurate one, atomic clock. Then where it is used? These uses of atomic clock. Atomic clocks are used in global position system, GPS system, and global navigation satellite system, GLONASS, and international time distribution services. The next one, Greenwich Mean Time, GMT. It is the mean solar time, Greenwich, okay. That time at the Royal Observatory located at Greenwich, London. Okay, Greenwich, London. It is measured at the longitude of 0 degree. The earth is divided into 24 zones. Okay, 24 zones, each width of 15 degree. Okay, 24 zones, each width of 20, and this width is what, 15 degree. And these regions are called time zones. Time difference between two adjacent time is in 1 hour. Two adjacent time, this is 1 hour. Okay. Next, Indian Standard Time, IST. The location of Mirzapur in Uttar Pradesh is taken as a reference longitude of Indian Standard Time. It is located at 82.5 degree longitude. IST, that is GMT plus 5.5 hours. Next one, what is error? The uncertainties of measurement are called as errors. Uncertain, not certain one. So that is called what? Error. The difference between real value and absurd value. That means, so for example, real value is 10 centimeter, but the absurd value is 10.1. So that is error. Okay, the difference between real and absurd one is called what? That is error. That is some uncertainties. So measurement, not accurate value. That is called errors. Clear? Next one, accuracy. Accuracy is the closeness of measured value to the actual value or true value. This is a closeness, not one, not almost close. Okay, so it is called accuracy. Closeness. Listen here. Here this is accuracy. Okay, most accurate one, yellow color. So nearest to this closeness of measured value. So this is called accuracy. Precision means the precision is the closeness of two or more measurement to each other. So this is most accurate one, middle. So here this is a closeness of two or more measurement to each other. This is called precision. Then difference between these two, accuracy and precision. Here accuracy means what? This is accuracy. Okay. So this is called precision. So which is most accurate means this is accuracy. Okay. Almost same. That is precision. Then approximation. This is the process of finding a number which is acceptably close to the exact value of the measurement of a physical quantity. That is approximately equal to approximation. Next one, a rounding off. The resultant containing more digits should be rounded off. The technique of rounding off is used in many areas of physics. So, what are the rules of rounding off? For example, this is 2.5351. So, here 5 is equal or greater than 5. If this number is greater than 5 or equal 5, consider as 1. So 2.53, add 1 to this 3. Okay, so 2.53. So this 5 is equal or greater than 5. So if you can add 1 to before number. So 2.54. Okay, next another one example, 2.5350. Here 53. Here also 5 greater than 1. So rounded off 2.54. Okay, next these are like examples. Okay, so, suppose it is an even this digit is less than 5, does not consider this value. Okay, for example 2.5349. Here this 4 is less than last value. Okay, this value is less than 5. So we consider what? 2.53, not consider this 4 because this value is less than 5. Clear? So what are the rules to be followed? Rules for rounding off. Decide which is the last digit to keep. Okay, last digit to keep. Which number we want to keep. Next one, leave it in the same if the next digit is less than 5. Next, increase it to 1 by 1. Suppose it is greater than 5 or equal to 5. Increase it by 1 if the next digit is 5 or greater than 5. Clear? Increase it by 1 if the next digit is what? 5 or greater than 5. Then we add 1. Clear? With the before number. Clear? So that's all. This lesson over. Thank you.